Welcome back, ladies and gentlemen. Get ready for quite possibly the most important project of your career, which I will explain and you're going to execute, and that is the importance of the sine bar. A sine bar is a tool used to create angles on parts. When you get in the real world, you will come across a part that's going to need an angle. It could be a simple 30-degree chamfer, 45-degree chamfer, or it might be a precision taper like a Cat 40, which is 7 degrees, 30 minutes, 15 seconds. Regardless of the angle, you can set any angle you like with a sine bar. The one thing you must know about a sine bar is the distance between the rolls. That is the distance that creates everything. In my example here, this is just a simple 30-degree setup of a sine bar. To figure out the sine, it's a pretty easy math formula where you take the sine of the angle that you wish to machine, multiply it by the center line of your sine bar. Again, the most common is 5 inches, but I've seen 10-inch sine bars, I've seen 15-inch sine bars, I've seen 20-inch sine centers. It doesn't matter, the formula is the same. Basically, you take the sine of the angle you want, which the sine of 30 degrees, I just know from experience, is 0.5, and you multiply that by your center-to-center distance, which, again, the most common is a 5-inch center. So if you take 0.5 times 5 inches, you come up with 2.5 inches. So that's how much gauge blocks you need for your 5-inch center to give you a 30-degree angle. As an example, I have a 30-degree parallel right here, which is 30 degrees. If I am to place it on the sine bar right now, that sure don't look straight, does it? But if I add my 2.5 inches of gauge blocks and I slide them under the roll, now it sure looks straight, don't it? And I can verify that with an indicator. I could take my dial indicator and run across that, and voila! It's perfectly straight. So I know I can prove it. That's the beautiful thing with the math behind it. And again, it's a very simple equation. Same thing with this. If I put this on there, if you zoom in, you'll be able to see that it's reading 30 degrees. So whatever angle you want, there will be your adjacent side of your triangle will change. Obviously, the more angle you want, the higher your gauge blocks of your opposite angle will be, and the less your adjacent angle will be. It's really simple trigonometry. But the importance of it is that known distance of this 5 inches, which is your hypotenuse of your triangle. And that is always going to either be a 5-inch, a 10-inch, a 15-inch. But again, let's just refer to the 5-inch because it's the most common sine bar there is. So you got a 5-inch sine bar, and that's going to be our project for the year, is making a 5-inch sine bar. Here's the print. Notice on this print, what is the most tight tolerance part on this sine bar? It's that 5 inches. So, to achieve that 5 inches, there are some EDM machines that could possibly hold plus or minus 1/10 on that 5 inches. But the best way to do it is with a surface grinder. Leave some grind stock on your 5 inches so that you can bump grind your 5-inch in. So once you got And obviously we're talking about a very precision tool here, so everything in your note, everything, all sides should be square and parallel within 2/10 also. Because you gotta start with something that's square, parallel, and perfect. So that's the important part about this piece, is that 5 inches and that everything's square, parallel, and total indicator run out of 2/10. Now when we get to the rolls, if you notice on this print, they have 2 different versions of rolls. Well, one is a dowel. It says 2 dowel pins required, or note optional piece of A2, where you're making two parts out of one, in which if anyone's ever dealt with a dowel pin, you know it's hard as a rock. Very hard to machine. It can be done. You just need very expensive tooling. You got to go at it with the best carbide out there, and I have done it, but I don't recommend it. Now, what is critical about it is that it is a 1/2 inch plus or minus a 10. This way is the preferred method in manufacturing that you will use, where this would be turned up, soft, machine, drill your holes, make it to the print, you'll leave some grind stock, and it'll get spun between centers, ground, and then they'll cut off the lugs, and you'll have the same thing, but a lot easier to machine. So give me a thumbs up if you're understanding it. Give me a thumbs down if you have no idea what I'm talking about, or give me thumbs to the side or middle if you kinda got it, kinda don't. I'm here to help. Anything I can do for you to achieve your project, you just let me know.